Hello, this is Uncovering Hidden Challenges in Query-Based Video Moment Retrieval. Video moment retrieval aims at locating a specific moment that matches to the given query sentence. There are two popular datasets: ActivityNet Captions and Charades STA. They provide untrimmed videos associated with natural language sentences and their timestamps. Deep neural networks are doing very well on this task, and the scores on leaderboard is skyrocketing. We investigate if this is a true progress. Our first finding is that we can build strong baselines by exploiting dataset biases. These orange bars indicate baselines that never use videos for training or testing. Another finding is that the state-of-the-art models often rely on language biases and ignore visual input. We tested two state-of-the-art models on original inputs and broken video inputs. Their performance did not show significant drop except one case. The last finding is that even humans cannot perform well on the benchmarks. Interestingly, the scores of human annotators are lower or on a par with existing deep models. This result suggests some issues in the benchmarks, such as ambiguity in temporal annotations and noisy ground truths. That's overview of our work. Let's move on to some deeper analyses. We address three research questions. Firstly, how well are the existing deep models on this task? To put these scores in context, we built some baselines. To build baselines, we use dataset biases. We found that there is a strong biases in target moments locations in query sentences. Here shows the distribution of target moments locations which correspond to queries with open. The horizontal axis is starting points of moments, and the vertical axis is durations of moments. This demonstrates that target moments corresponding to open are likely to start at the very beginning of the video and last roughly 20% of the video length. Let's see more examples. Moments locations associated with different verbs have different trends. Now, we can expect that we can guess the locations of moments using only verb in query sentences. In this work, we develop three baselines which uses dataset biases at different levels. Prior-only blind predicts temporal locations of moments without using videos or query sentences. We precompute a prior distribution of moments locations on a training set. On testing, this model just samples proposals from a prior distribution. Action-aware blind uses only verb in a query sentence. This baseline uses a prior according to the first verb in the query. Lastly, this baseline uses whole query sentence. This model is built by removing visual input from a state-of-the-art model. We train this model to predict moments locations only from query sentences. Surprisingly, our blind baselines are competitive or even outperform some deep models. Here is the prior only. This does not use videos or queries. Here is the action-aware blind. This uses only one word in a query. And blind tan, which uses a whole query sentence. Note that these orange bars are baselines which never use videos for training or inference. We observed baselines using dataset biases perform unexpectedly well. The results suggest that the deep models might also rely on priors. To clarify this point, we investigate if the deep models use videos for their prediction. Suppose we have a model which takes a video and a sentence query as input. We break the input video by temporal shuffling and check how predictions change. If the model learns to use videos for its prediction, the performance should significantly drop. Here is the results. Except SCDM on Charades STA, these models hardly change their outputs even with broken videos. This looks that both of the models give up watching videos on ActivityNet Captions. Lastly, we investigated human performance. To get human performance, we partially re-annotated the datasets. On Amazon Mechanical Turk, we asked cloud workers to solve moment retrieval task. We observed that human performance is not very good compared to the deep models. One reason why even humans fail to locate moments is the ambiguity in the annotation. The purple areas are temporal annotations by cloud workers. They specify different moments, but actually both are valid. A video can have some valid moments for a query, but current evaluation metric does not consider this types of error. We provide the newly collected annotations and describe how we can use them for more robust evaluation in the paper. To summarize, this work provides some findings on query-based video moment retrieval. Our implementation and recollected annotations are provided on this link. If there are any sort of questions, please don't hesitate to get in touch. Thank you for your attention.